Be sure you show your steps on the test. Step number 1 says isolate. That means that this absolute value bar right here has to be isolated. There should be nothing on the outside. We're going to isolate it by getting rid of that 5. What is the 5 doing to the absolute value bars? It's saying 5 times. Divide both sides by 5. So the result of isolating is the absolute value of x plus 2 is equal to 3. So this is the result of step number 1. Step number 2 says separate. So we take this x plus 2, leave the absolute value bars off, set it equal to -3, and then take the x plus 2 and set it equal to +3. That's separate. I think in my notes I originally said split. Set it equal to -3 and +3. Then step number 3 says to solve each one. So I'm going to solve each one of these by getting the x by itself. And the two answers that I come up with are x equal -5 and x equal +1. So I come down here and put a dot on -5, and I come over here and put a dot on +1. Don't know why that. There we go. Step over here, step number 1 says isolate. What do I have to get rid of? I have to get rid of this +1. So absolute value bar, x minus 1, absolute value bar is greater than or equal to 4. I've isolated the absolute value bar. Now I separate. When it's an inequality and I separate, when I write down the -4, I switch the direction of the inequality. I also look at this inequality once it's isolated. I look at this one to tell me that this is going to be an OR problem because it's pointing to it's greater than, so it's going to be an OR problem. That means when I get this graphed in a minute, it's going to be shaded on the outside of my 2 end dots. That's what that symbol right there tells me. So I switch the inequality for the -4, put the word OR, and I leave the greater than inequality there for the +4. Now that's separate. So this is step number 1. This is step number 2. Step number 3 is going to be where I get the x by itself. So I do the opposite. +4, +4, +4. And x is less than or equal to, I believe that's 5, or x is greater than or equal to, I believe that's 8. Well, 8 is not on my number line, so I'm going to have to extend it on out. 6, 7, 8. And it's going to be here at 5 with the filled-in circle, and at 8 with a filled-in circle. This one's going to be graphed this way, all the numbers that are less than 5. This one's going to be graphed this way, all the numbers that are greater than 8. Isolate, start with the 4. I'm still isolating. And separate x minus 1. Switch the direction of the inequality and get -3. Look at this one right here. That is an and it means I'm going to have open circle filled in between. So I anticipate that's what my graph is going to look like. X minus 1 less than or equal to +3. So step number 1, this is step number 1, isolate. These 2 things right here are step number 2, separate. Step number 3 is to solve. I add 1 everywhere to solve. X is greater than -2. X is less than 4. So open dot on 4, open dot on -2. All the numbers bigger than -2 are this way. All the numbers that are smaller than 4 are this way. That's -2, that's +4. That's what my graph looks like. Label these as either 1, 2, or none. I would highly encourage you to use your graphing calculator. I'm going to pause the video so I can open it. So when you're trying to determine whether one of these problems right here are going to have either 1, 2, or none solutions, to do it by sight, you can't answer that question until you isolate the inequality, and you isolate the absolute value. So we've got to get the absolute value bar alone. So what needs to be undone? We need to get rid of this negative sign in front. How do we get rid of the negative sign? If we get rid of the negative sign, we can do that by dividing both sides by -1. So you divide this side by -1. You divide this side by -1. My pencil's writing too thick. And then you end up with your absolute value bar isolated. It's just x plus 2. And then that's equal to a +7. Since it's equal to a positive number, we're going to have 2 solutions. You can also use your calculator. So I'm going to pull up my calculator right here. I've opened a graphs page. If you're not sure how to do that, on the home button right here, you can click the home button. You can go to this thing right here and it'll open a graphs page. I don't want to do that because I've already got some things graphed and I don't want to lose them, so I'm going to go back to number 4 right there. So you can also, if you're on a graphs page and nothing is happening, just hit the tab button and the first available line to graph something on will pop up. So why does mine pop up on the 7th line? That's because on all of these other things, I've already got some of these problems over here worked on another page. So it popped up on the first available line. So all I'm going to do is type in the problem that was given. I'm going to put in the negative sign. That's this sign right here, the negative sign. I'm going to use my absolute value bars. I have to hit the template button and then click on the absolute value bar. And then I'm going to type in x plus 2. That's all I'm going to type in on that line. And when I press enter, it's going to graph the absolute value part for me. I'm going to click the down button. And that way I can type in the other side. I'm going to type in -7. And I'm going to type in, try that again, -7. I'm going to press enter. And I'm going to have to move it a little bit because I knew that I couldn't see my -7 graph. I see it wasn't quite there. It was like it's 6 something while ago. So I'm just going to drag that up. And now I can see that those two things intersect each other at 2 different places. So there's one solution right there. There's the other solution right there. So I was right in that it had 2 solutions. So to isolate the absolute value bar, I would add 4 to both sides. That's going to give me 0. That's my clue, because when I add 4 here and I add 4 here, that's going to give me 0 right there. When my absolute value bar is set equal to 0, I know I'm only going to have 1 solution. If you're wondering why that is, that's because it's going to look like that. You got the absolute value bar, the 2x minus 4. Down here, you've got the -4 graphed, and they're going to intersect each other right at that vertex. So there's just going to be one intersection. This next one, the absolute value bar is already isolated, so it's set equal to a positive number. So you should know that this one's going to have 2 solutions, and I've already got it graphed right here, and you can see the 2 solutions right there where those 2 things intersect. Those are solutions right there. And last but not least, these 2 are not going to intersect at all. So what happens over here when we are isolating our absolute value bars, we end up with the absolute value bar being equal to a negative number. And that's how we know that there are no solutions.